Welcome to Brains on Games. I'm Dr. Brian McDonald, and this episode we're going to be talking about a game that I think teachers are really going to like and appreciate as something that could be really helpful for them in their class. And you know what? For parents at home too, it's a math game called Mathemagician's Duel. This is a game that can be played with between 2 and 3 players. It takes about 20 to 40 minutes to get through it, and it's good for kids aged 8 and older. Okay, let's take a look at what goes into Mathemagician's Duel. You can see right here we've got these cards with these characters on them. There's 4 different characters in the game, and it doesn't really matter which character. You're just going to draw them randomly. Really, I think that they were put in here just for variety's sake. So we'll just focus on 2 of them because typically you'll be playing this as a 2-player game. Now, here, these cards are spells. You know, the game is called Mathemagician's Duel, so there's math and there's magicians, so you've got these little wizards on here. And what you're trying to do is cast spells that will reduce your opponent's health from 20 down to 0. Their magical strength, they call it here in the game. You can see that here, -3 and -3. Now, you draw these spells, and each player is going to have one on the board that they're working on completing. And in order to complete a spell like this, you've got to create a math equation. They call it an incantation in the game. So incantation and equation combined. A little portmanteau there. I think that's the way that word is pronounced. Okay, let's look over here. So you've got this equal sign. And what that means is that your equation has to equal that number. And if you can get your equation to that number, you can say my spell is cast. What's interesting though is that your opponent is going to double check your work, and if there's a mistake, the spell comes back and hits you instead. So you'll want to equal this number, a 4, here you've got a 9. You have to have at least this many digits in that equation that you're working on. So that means that you've got to get to this 9, but you have to have at least 3 cards or more. So you're drawing cards from 2 separate decks. One has digits here, you can see from, well, it goes all the way up to 9. I just drew a couple out of the deck just so you could see what they're like. The other has pluses and minuses, so you're adding or subtracting in order to develop this equation. What complicates things is that your opponent can put numbers or operational symbols in your equation too. So you might be working up to get that number 9, but they might put a minus sign and you needed a plus. And so that's going to slow things down for you. You're going to be keeping track and juggling a lot of numbers and doing a lot of calculations. You've got to get a total of 9 or 4 or whatever the number is on your spell, and that has to be done with a certain number of digits. So you're constantly adding up your equation, and it gets longer and longer. You might have, I know when I played it, we had 6, 7 numbers on this equation, mostly because my son was trying really hard to mess up what I was trying to do, and he wasn't as worried about his own numbers. So he was always looking at my equation to see what the number was adding up to. And he was also focused on these numbers here because he could cast his spell if the number of my equation got to the number that he needed. All he had to do was claim it at that time. So you're constantly adding and subtracting and trying to solve these equations. So you're doing mental math, and it's repeated. You're going to do those over and over and over again to try and keep, you can't just memorize the equation because it's constantly changing, and the totals that you need are also changing. So you're doing mental math, and what that's going to be working on is also developing your automatic calculation skills, right? You're going to start to memorize some of those combinations or start to see patterns in the numbers emerge. But you're also juggling a lot of numbers. You've got to remember the total of your spell, the total of your opponent's spell, the total of your equation and your opponent's equation. Those numbers are constantly changing, and we've talked before about that special skill, working memory. Working memory is like the whiteboard in your mind where you keep information so that you can juggle it around. And it's really important when you're doing mental math. I mean, you might be able to remember 2 or 3 or 4 numbers, but as soon as you start to combine them or change them around somehow, that's a working memory exercise. So you're working on working memory, and you're developing those automatic math calculation skills. And this is why I thought it's a much more direct math game than most of the games that we've talked about. Pit Crew is another one where you're doing some of that, but the numbers aren't changing as much here. You're always with Pit Crew, you're working up to a total. You're not adding and subtracting and changing things around as much as you are here in Mathemagician's Duel. Now, a couple of days ago, before I was lucky enough to go and get this amazing haircut, I was also lucky enough to have a chance to speak with Scott Kelly, who's a teacher and also one of the designers of Mathemagician's Duel. Here's our interview.
Teaching was a midlife career change for me. Because as far as making games goes, I did end up working for a Games Workshop.
Oh, wow.
Yeah, so, mail order, warehouse, retail in the store. So I wasn't in the studio designing, but when we had our big events, rather than just playing the main core games, we had little side tables with games that people could come and try out. And I started creating games for that. So I take the core properties and things that we already had as Games Workshop, and I'd make like little mini games out of that. One of my favorites was Squigitch, where I took Quidditch from Harry Potter, and instead of wizards and witches on brooms, it was goblins riding wolves, and then squigs, these little creatures were hopping around instead of the balls, right? Things like that. So I create these games for those. But again, it was just for events. So moving ahead again. Then after I left there, I went into teaching and started to think, why not bring all this gaming that I enjoy into the classroom? Because a lot of kids, you say games and they say, oh, Monopoly, sorry. Right. And that there's a very limited, whatever's on that one shelf in the Walmart or the Toys R Us are the ones they're familiar with. And once in a while you get some of the students who are from families that did more gaming, and they'd recognize Settlers of Catan and things like that, for example. Some of them, I remember a couple of students really being at a Risk. They played that at home, so they had a better idea. But I thought there's intrinsic value in pretty much any game as far as teaching the social skills, how you communicate, the turn taking, the negotiating, how you're going to get along and play together, even when you're playing competitively. So I felt there's a lot of that. And then just on top of that, you've got your adding up your point values, probability. What's the chance this is actually going to succeed if you're playing games that have dice or you need just the right card, that sort of thing. So all those together. And then once you throw in games that are actually themed on something historical, for example, then you have all that background in there as well.
What do you think about games versus lectures or drills or exercises that most other teachers are doing?
It needs to be interesting and engaging. That was my thought. Yes, explicit instruction, I believe, does have to be there. With Mathemagician's Duel specifically, I don't know if this is something I might be preempting a question you had coming up later. When I conceived of the idea, it wasn't so much about learning how to do the math, but practicing the skills. The reason I decided to do it this way was watching kids playing Pokemon, Yu-Gi-Oh! I played Magic when it first came out, Magic the Gathering. And every time I tell the story, I lament, if only I'd kept those cards, they're probably worth hundreds of dollars. It's like the first edition, the first set of Magic when it came out. But the kids, they know all the characters. They know all the stats. They know who they all are and what they all do. And there's this great amount of memory power and brain power going into this. Yet there's a lot of retention or thinking going on often in school because it's not interesting. It's not something you want to talk about. You're telling us all these facts and making us learn these things, and it's gone like 3 days later. Yet with these games, it's there, right? They know all the stuff. So I thought, why not take what makes that game fun, but apply a topic to it that will have some long-term learning outside the game itself.
How do you see parents and teachers using this game as a way of helping their kids develop those skills?
Playing with students too. Watching them is really interesting if you're playing with them or watching two students play, because it gives you a sense of where they're at, what they know, and how they do math.
Right.
This is really interesting. Well, I think so. You can judge. But part of the game is you can pull cards out of your in-can equation. that you've created, right? So you're building your equation, you put down a number card, an operations, number and operator, number operator, until the value of that, when read left to right, equals the casting value on the spell that you've chosen. So I'm trying to hit maybe 15. That's the number I'm trying to get to. So every turn I'm playing my one card onto my incantation. But you can play onto your opponent as well to mess them up. So sometimes the incantation's getting kind of long because your opponent's going, take this, and they're throwing cards at you to prevent you from getting the number you want to. So you can take a card out. You pull out a number, and you can take with it the operator on either side, the left or the right. Now, while I was sharing this in my class, I was in a grade 7 math class. I'd just taken over for it was a maternity leave. So I came in November. They'd already done the integers unit, right? So they've done negative numbers. And I watched a student playing, and they had their incantation laid out in front of them. And it's fun to watch because once they get to realizing they can do that maneuver, they will cover, see here, if there are cards out in front of them, they'll cover 2 cards, recalculate the entire line. Then they'll cover 2 more cards and recalculate the entire line, and cover 2 more, and just to see what would happen if they took each of those out. So on their turn, they've added their entire thing 7 times, just to see what the difference would be if they pulled one of those numbers out. So this one student, there's a minus sign and then a 2. And he kind of pulls those out of the line of his cards, and he adds them up. And he looks confused, and he puts them back, and he adds it up again. And he pulls it out, and he adds it up again. And he goes, if I take out minus 2, my overall number gets bigger. I said, yes, that happens. And he pauses, and he goes, that's what she was trying to tell us. And I said, so you spent 2 weeks before I got here on subtracting and adding negative numbers, and now you understand what happens when you subtract a negative number? And he goes, well, it makes sense now.
Right.
Well, because he's had this really concrete example that literally laid out in front of him, that he's worked on his own, and kind of come to this conclusion, which was shown to him before, but at the time he wasn't really absorbing it. So I think it's really neat to see what sort of conclusions they come to playing with the numbers, right? And even just finding patterns where they'll be reading left to right and they're adding it up because they forgot what number was I at. So 3 plus 2 minus 4 plus 4, and they'll go, wait, minus 4 plus 4. That doesn't make a difference, then that cancels out. So every time they add it up after that, they'll just skip over the plus 4 minus 4 to save themselves time because they recognize that it cancels them out. And I don't ever recall telling any of the students playing any of these, because you can also see common errors, right? So if they're adding, I'm at 7, and they add 8, and they come up with 16, and they do it over and over again, then again, we're noticing that there's a common error or something's stuck in their head that they're going to have to sort of unlearn or be shown explicitly again for them to really understand how that works. So the observation
So a teacher or a parent who's playing with them can make those corrections immediately and help to prevent those things, the errors from becoming automatic, because that's the problem in that situation. Right. The error is automatic now instead of getting the automatic correct calculation.
There you go, right? So especially if you're in a situation where things are getting marked wrong, like on a worksheet or something like that, and you go, oh, it's wrong. And a lot of students go, oh, well, I didn't get that mark. And they move on, right? Not a lot of them will go back and say, where did I go wrong? Whereas in the card game, it sort of forces them to look at it because your opponent is constantly checking. Because if you declare your spell as cast and you go, oh, I reached 15, before you can have it cast, your opponent is written into the rules, gets to double check, and they have to make sure it's correct. And they go, oh, that's actually 16. I think you miscounted here. And then you prove it to them. The spell still gets cast, but it backfires on the caster.
Right.
So it is in your best interest to make sure that you've got that correct, and it is always double checked. And that real-time feedback, I feel, is also a benefit over a lot of the video apps and websites, because I have observed, and a lot of them are pretty good. They engage the kids, they're fun, they're interesting, they give them problems in ways that the kids want to solve them. But I have observed a lot of guessing going on some of them, where students will just keep putting in numbers till they get it right.
Right.
And so they don't get that feedback of why is that right or why were these other ones wrong. So the board gaming in general, doing things with people physically in front of you playing a board game where that cooperation and agreement is necessary, it doesn't allow you to sort of guess your way through until you get to the end and claim that you're done. So that's another reason that I like the board games in general as a method for practice and engaging work.
Yeah. Well, and it is really engaging. I played it with my son who's in university. Yeah. He's taking a biostatistics course right now, and he's doing this basic addition and subtraction. And he's like, what a brain exercise. I haven't done this kind of math in a long time. He said, I need a copy of this game at home so I can continue to practice it. Now, one of the things I wanted to make sure that I asked you, because as soon as I opened up this box, I had a question right away. The box says level 1.
Yes.
What does that mean?
We're currently working on level 2 right now. Play testing it. Level 2 includes multiplication and division.
Okay. That's what I was hoping, honestly. Yeah.
Yep. In addition to the addition and subtraction, it includes multiplication and division. We're just working on the balance of numbers of cards. The play tests I got so far indicate to me that I do need to add a few more operators. And the third level will include the addition, subtraction, multiplication, and division from the first 2, plus all the numbers will be negative.
Oh, wow. Okay.
So the third one will be integers. So even if you feel, or once you feel that, you know what, addition, subtraction, I got it, I'm pretty good at this now, I need something a bit more challenge, or the kids or your students, right, as they move up, there's still something for them to continue to challenge them. So you can use it at higher levels, right? You could see it with the multiplication, division, negative numbers in high schools, right? It doesn't have to be limited to grades 4 to 6 or 8 or whatever, because you feel it's a bit simple for what they're doing. But like you said, we found that same thing your son said, that people, a mix of reactions when we were play testing it, because we go to game cafes and game conventions and we get people to play, and people will either go, okay, I'll try it, math is pretty simple, and then they get into it and go, wow, that is a bit more than I thought it would be. But at the same time, we have people going, oh, is it a math game? I don't know. I don't feel, I'm not really good at math. I'm like, you're an adult. It's addition, subtraction. All right? You shouldn't be intimidated by this. Right? So that is another interesting phenomenon. I know that goes into a lot of the math anxiety. And I did write on the blog, actually, on our website, a piece called Why We're Teaching Kids to Hate Math. Where I kind of adjust my thoughts. I didn't do a lot of research. I linked a couple of different sites to talk more about that. It is much more of an opinion piece, but I thought I really felt I needed to speak out about it being okay and socially acceptable to go, oh, I'm not really good at math. And I want to go, yeah, because math's hard. And we're talking about addition and subtraction. But I kind of started off my story a bit there. So we would get some of them, though, convinced, oh, that's fun. Look, there's cute little wizard characters on it. And they go, okay, I'll give it a try. And they'd sit down, and halfway through, they're really into it, right? They're adding up. They're trying to figure out, oh, what number would I need next? Should I use this number to attack you? Does that make it worse for you, or is that going to help you? And partway through or towards the end, the feedback we get was, I didn't feel like I was doing math. I forgot about the math part. I was just playing a game. I'm like, well, that's exactly what we're going for. Right? But to get over that initial, oh, it's got math, it's an educational game for kids, right? To get past that we're finding a bit of a challenge. But we're hoping that we can break a bit of that stigma. However, I have thought of maybe an expansion where we throw in zeros, because that would really change the way the game plays, and maybe parentheses, where you can put 1 in your Incan equation and it means nothing. But when you put that second one in, then you got to calculate that part before everything else. So that might mix things up a bit. But I think that'd be definitely an expansion for the advanced. But we'll test it. We'll see how it goes.
There's a good way to increase math anxiety when people are playing it. Add parentheses. Perfect.
Yeah.
Scott, thanks so much for talking to me today. I really enjoyed your game. And like I said, my son says he wants to play it again, just to practice those basic math skills.
Awesome. And that is the intention. All right. It says 8+ on the box. That doesn't mean 8. It means 8+, right? But you can't put like 8 to 99, because people living longer these days, I don't want to exclude the centenarians.
Let me ask one more question before we
Sure.
go. If
Yeah.
people have some questions or if they want to find your game, how can they track you down? How can they track down Mathemagician's Duel?
Oh, we're at www.bsgames.ca. Right, if it's CA, not .com. The BS and BS Games stands for Bill and Scott, so you know. There is a link on our website so that you can order it online through our website. However, right now what we're asking is if you're in the Southern Ontario area, maybe even further out, if you go to the Mathemagician's Duel page specifically, at the bottom of the page is a list of retail stores that carry our game. We're not super huge, big in all the big outlets yet, but there are a few hobby stores and game stores that carry Mathemagician's Duel, and I'd really like you to have a look at them first, because I'm doing this as a secondary job. I'm doing okay already anyway. Even through the situation that we have with COVID, a lot of stuff is shutting down. I'm able to work from home, so I'm still working. But a lot of these stores, these little game shops, this is all they do. And not having all the traffic coming in for the past couple months is really difficult for them.
Yeah.
So I would really ask everyone to go and see, because a lot of them are offering it online and they will deliver or ship. So check with them. If you can get it through them, get it through them. And if not, you can come back to our website and we'll ship one to you.
Great idea. Support your friendly local gaming store.
Please, yes. Please support them.
All right. Thanks again, Scott.
Cool. Thank you very much.
So that's an overview of Mathemagician's Duel, a quick game that can be played in under 40 minutes that requires automatic math calculation skills and working memory. If you have any suggestions for me or questions about the games that we've talked about on the show, you can find me at brian@brainsongames.ca. Brainsongames.ca is the website where all the previous episodes are posted, and future episodes will be there too. Brains on Games is the Twitter handle and the Instagram handle and the Facebook page, so we're all over the place. And if you like this video and you want to get notifications when future videos are posted, just head on over to YouTube and click that subscribe button. Hopefully you like this one, and hopefully we'll see you next time.